Last part of our wonderful, fantastic semester review video here, part 3 of 3. The trilogy of trilogies here, really, is what I'm saying. Alrighty, let's go. Slope, Pythagorean theorem, and special right triangles, Unit 2A for the 2021 semester 1 final exam. So the following ramp has a slope gradient of 30%. What is the slope of the handrail represented as a fraction? Well, the slope is a 30%. That's 30 over 100. Which can reduce to 3 over 10. Final answer. What is the slope of each of the supports? They're perpendicular, right? The supports are perpendicular. So we have to do the opposite, which would be negative, and reciprocal, which would be 10 over 3. Done. Final answer. Awesome. All right. We're cruising. G easy. Plans to build a ramp to make getting into his house easy. I remembered the Z on that one. For his grandma. He plans to build a ramp to have a 1-inch rise for every 20 inches of run. He needs to account for 3 feet of rise. I'll mark that down. 3 feet, which is 36 inches. I don't know why I use different notations. Boom. All right. Label all 3 dimensions. We've already got 1, right? Now I need to figure out, how about this? 1-inch rise. So my run is 1-inch rise for every 20 inches of run. Do I know the rise or the run that I want? I do know the rise, which is 36 inches. And then I can figure out my run by, how about cross multiplication? So I'm going to have 1x equals 720. 20 times 36. 2 times 36 is 72. Pop a 0 on there. Boom. All right. 720 inches. All right. Now I'm going to need to bust out that TI-84 plus graphing calculator. Yo, bro. You only round once. Mathematical accuracy, right? Right? Okay. So let's see here. Why am I busting out my calculator? What am I about to do? How about a little bit of Pythagorean theorem? I've got myself a right triangle right here, right? So 720 squared plus 36 squared equals C squared. This being C right here, my hypotenuse. So I'm going to do that in the calculator. 720 squared plus 36 squared. That's going to be a huge number. That is 519,696 equals C squared. Got a square root on both sides to get rid of that bad boy, that exponent. And I'm going to get C is equal to 720.899. So we'll say 720.9 inches. We got all 3. We're good to go. I love it. Fantastic. That's all I needed. Next one. You're cutting rafters for a shed build. The roof has a 1512. Woo! That's a steep roof. Approximately 51 degrees. What angle measures will you use when planning and cutting the seat and heel cuts? Again, if you take a look here at this little notch that comes out, it's a little triangle out of our rafter. And I'm going to go ahead and enlarge this just a little bit. So here's my rafter end. All right. There we go. And then there's this. This is terrible. Go up, over, and then it continues on. Okay. So that's my that looks awful. Okay. I don't even like that. Anyways, in there, I'm going to just enlarge the triangle cutout. Let's go with that. Okay, so that's my triangle cutout that I've circled, right? That's this right there. That's a right angle, okay? And one of my angles is 51 degrees. Let's call it this one for now, right? It varies as to how you lay out your speed square and stuff like that. But what's going to be left over? Well, I know there's 180 degrees in a triangle, right? Or I can say that I know that these 2 angles here and here are going to end up being complementary because there's already 90 degrees accounted for. In any event, what we end up doing is we have 39 degrees for this one. 51 plus 39 is 90. 90 plus 90 is 180. So what angle measures will we use? 51 degrees and 39 degrees. Final answer. You are constructing stairs that need a total of 7 steps. Not necessarily what's pictured here. This one only has 5 steps. 6.5 or 6.25 inch rise with 11-inch run. I feel like we've dealt with that before. Okay. What length 2x12s would you need to purchase? Okay. Well, usually with we've been setting up proportions for things, but that's to get a different. I don't think we have that situation here. What I'm dealing with is a triangle here being cut out. That again is I'm struggling with my triangles. Let's see if I can ink to shape. That's pretty good. Okay. I like that. So I'm figuring out, I got a rise here, and I'm going to take this. I'm going to move it over here. I've got this rise of 6.25 inches, and I've got a run of 11 inches, right? 6.25 and 11 for those two pieces. That's going to be a right angle because I'm cutting out these perfect notches for stairs, right? It's not going to be some weird angle. Could I figure out what that length is right there? Yeah, it's a right triangle. I can use Pythagorean theorem. 6.25 squared plus 11 squared equals x squared. So if I plug that in my trusty TI-84 calculator, which I'm always strapped with, right? I never go anywhere without this thing. I'm going to run some errands in a little bit. Back pocket right here. I'm kidding. I'm not going to do that. So I got 160.0625 equals x squared. Now I'm going to square root that to 0.25. And I'm going to get 12.6515, so on and so forth, for x, okay? That's for one stair. So I have 7 steps. I'm going to multiply that by 7. So this 12.6515 and change, I always put like a little dot, dot, dot saying like it goes on forever, times 7 equals, and that's 88.56, so 88.6 inches. That is a wonderful math answer right there. If you're actually going to the hardware store to pick this up, I'm going to convert that to feet. So I would convert it to feet by dividing by 12. This is not necessarily part of this problem, but the 88.561, so on and so forth, divide that by 12, and I get 7.38 feet. So I'm going to get an 8-foot 2x12s. That's what I'm going to be ordering at the hardware store. Okay, I'm going to be like, hey, man, I need, 3 8-footers to make this this stair stringer or whatever, and then I'll bring it home and I'll cut it out because I love to build things, right? Okay, cool. Simplifying radicals. We love doing this. Factor tree. I'm going to divide by 2 first, and I get 100. If you're real good with this, you'd be like, dude, square root of 100 is 10. I'm done with this. But we're not all quite there with catching on to the perfect square. So I'll just keep going by 2, and then I get 50, 2 and 25. That's not divisible by 2, not divisible by 3, but it is divisible by 5. So I got a pair of 5s, pair of 2s, multiply those together. That's 10 with the 2 left over. Final answer. Okay? But if you saw that perfect square of 10, you could have taken the square root of 10, take it out. 2 is left inside. Okay. 48. Well, 2 and 24. 2 and 12. 2 and 6. 2 and 3. Pair of 2s. Pair of 2s. So 2 times 2 comes out. Times 3 is 12 root 3. Lovely. Distance. So I've got the square root of x2 minus x1 squared plus y2 minus y1 squared. So I have negative 6 squared. Man, it is windy. I don't know if you guys can hear that. The garage doors moving and stuff like that. It's windy out there today. That becomes positive there. So negative 1 plus 3 is 2 squared. So I get 36 plus 4, which is the square root of 40. Can I leave it like that? No way. Not in this problem anyways. Simplified radical form. I'm going to break it down to 2. Oops. I'm going sideways, though. I'm running out of room. 2 and 20. 2 and 10. 2 and 5. Got a pair of 2s. So that's 2 root 10 for my final. I feel like there's a terrible spot for that answer. That's so disorganized. 2 comes out, root, and then 2 times 5 was our 10. So there's my final. That's a little better, I guess. All right, next one. So I've got x2 minus x1 squared plus y2 minus y1 squared. So I've got negative 4 squared plus negative 4 squared. So that is 16 plus 16 in my square root. That's the square root of 32. Let's break that down. I'm going to get 2, 16, 2, 8, 2, 4, 2, 2. Oh my goodness, so many 2s. Pair of 2s, pair of 2s. And I've got a nice little spot up here. So 2 times 2 is 4. Square root, what's left over? 2. Okay. Slope time. I'm getting tired, man. This is a lot of math. But it's a good amount of math, right? It's good math. I'm going to stay hydrated, right? No, not the Bubba right now. This is one I'm carry around at home, right? Bubba's at school. All right. I don't leave it at school. I brought it home, but I'm using this one right now. Okay, slope. Change in y over change in x. So it is, my slope is y2 minus y1 over x2 minus x1. Make sure you stay in the same order. Whichever order pair you start with in the numerator, start with in the denominator. Negative 10 over negative 4. This is positive 5 over 2. Does not look like a 2 anymore. There it is. All right, next one. Again, our slope, change in y, negative 2 minus 1 over the change in x, 7 minus 1. That gives me negative 3 over 6, which is negative 1/2 for my final answer. Woo! Awesome. Cool. Next one. You're planning to pour a concrete patio, and you want it to be a 12 by 11-foot patio and 12. I changed the dimensions and did not change my grammar. Okay. What length should you get if you measure it from corner to corner diagonally to ensure that you have right angles? Round to the nearest 10 if necessary. So I draw this up. 12 foot by 11 foot. What am I going to get if I measure there? I'll call that x, right angle. That's what I want, right? Pythagorean theorem it is. 11 squared plus 12 squared equals x squared. So 121 plus 144 equals x squared. That's going to be 265. Now I really need that calculator because I got a square root on both sides. So square root of 265. That gives me 16.278. So 28 feet. All right. Wonderful. Again, I'm not happy with how these things are circling. That's better. I think I just need to move a little quicker, right? Otherwise, I'm like, all over. All right. Classify the triangles as acute, right, or obtuse. So 8, 15, 17. That is actually one of our triples. But if we want to show the math, 17 squared, and then I have 8 squared plus 15 squared. That's going to be 289. And then I have 64 and 225. So that becomes 289. And this is 289. So I get equals. That is a right triangle. All right. Since it was a triple, right, it would fit the Pythagorean theorem. We know that that's going to be a right triangle. I'm going to switch colors. So here I get my largest square is 12 squared. And then, I don't know. And then I have 9 squared plus 10 squared. So I got 144, 81 plus 100. That's going to give me 144, 181. That's less than. So this is acute. Next one. Change colors again. Green. C squared is my 18. Then I got 11 squared plus 13 squared. Make sure that looks like a 13. There we go. So I've got 324. And then I got 121. That's a crazy one. Plus 169. If I add those two together, I get 290. 290. 324. That is greater than. So this is obtuse. Exclamation point for whatever reason. All right. Very nice. I want to double check that is indeed 320. It is 324. Awesome. Cool. Whew. Number 10. The slope of the gable end roof of a gable end roof is 812. If the building is 36 feet wide, how tall is the roof? If you're framing the roof, how long would the rafters, the slope part, be? Draw a picture. So I'm going to draw out this gable end roof. We've seen this before. Just the roof portion would be this. Pin the ridge. There's going to be other ones in there as well, but we're not really worrying about those lengths, so this is what we'll work with. I got an 812 pitch. That is rise over run. Well, I've got a 36-foot wide building, which means that this right here is going to be 18 feet, right? Halfway across. That's my run, so that's my 18 here. My X is going to be my rise. Let's cross multiply. I got 8 times 18, and that is going to be 144 equals 12X. Divide this by 12. That's 12. X equals 12 feet for my rise. Okay. So that's the first part. 12 feet. How long would the slope part be? That sounds like some more math. Well, I've got a right angle, don't I? So I've got 12 squared plus 18 squared equals, we'll call it y squared. That's going to give me my rafters. So 12 squared plus 18 squared. I mean, I already did these, but we had, what was that, 144 plus 324 equals y squared. So that's going to be 468 equals y squared. Yep. And then I'm going to square root on both sides. And I get y equals 21.63, so 6 feet. Cool. Got both parts. Fantastic. Oh, special right triangles. Special just like all of you guys, you know, right? We love the special right triangles. They're so great. All right, time for some super proportions, right? Let's do it. This is a 45, 45, 90 triangle, so it's going to have the 1 root 2 triangle, or root 2 proportion. Now, across from a 45 is U. Across from the other 45, which that's 45 right up here, that's V across from it. And then I've got 10 across from the 90. Cross multiply, I'll do U times root 2 equals 10 times 1. And then I'm going to divide by root 2. So I get U equals 10 over root 2, but we know we cannot leave it like that. I need to rationalize. So I get 10 root 2 over square root of 2 times square root of 2 is square root of 4, which is 2. And then I got to reduce that to 5 root 2. Now, since U and V are both across from the same measure angle, U and V equal the same thing. So we're done. Cool. All right. Next one. I've got a 30, 60, 90. And I've got, let's see here, 1, root 3, and 2. So I'm going to have, let's see. We'll go with y over the, is across from the 30, right? Because that's a 30-degree angle. Okay. Across from my 60 is 3 root 3. And then across from the 90 is x. So I'm going to cross multiply and solve. For y, I'm going to have y root 3 equals 3 root 3 times 1, which is just 3 root 3. Now I got to divide by root 3. Now, usually we're like, oh, gosh, I'm going to have to rationalize. But these cancel, and I'm left with y equals 3. Nice. Now I'll solve for x. Some of you might be like, well, if I know the short side, can I just double it and get the other one to be 6? Yes, but I'm also going to work it out. So I'm going to have 3 root 3 times 2 is 6 root 3 equals x root 3. Divide by root 3. Cancel, cancel. I get x equals 6. Cool. Now, 30, 60, 90 again. This guy right down here is my 30. So I've got 1 root 3, 2. Across from my 30 is 10. Across from the 60 looks like V. And then across from the 90 is my U. Cross multiply and solve. Actually, this one works out really nicely. 10 times root 3 is 10 root 3. 1 times V is just V. I'm done with V. And then for U, it'd be 2 times 10 is 20 equals 1 times U is U. I'm done with that. That one was nice. Not too bad. Not too bad. All right, next one here. Another 30, 60, 90. We must love these. 1 root 3, 2. Across from my 30 is a y. Across from my 60 looks like the 6. And across from the 90 is x. We're going to cross multiply and solve for y. So I get y root 3. Why am I struggling with my 3's? Root 3 equals 1 times 6 is 6. Divide by root 3. And I get y equals, that cancels, 6 over root 3, which we cannot keep. Got to rationalize. And some of you are noticing some patterns, and that's cool. I get 6 root 3 divided by 3. And then I got to reduce to 2 root 3. So y is 2 root 3. All right. Now for x. I'll change colors for x so it doesn't get all mishmashed. We'll go with green. So I get 6 times 2 is 12. And then we have x root 3. Divide by root 3. And some of you might be like, dude, can I just multiply by 2 since I have the short side? You are correct. But I'm going to go through this. So we get x equals 12 over root 3. Rationalize. And then I get 12 root 3 over 3, which does reduce to 4 root 3. And as we said, it is double. the y. 2 root 3 times 2 is 4 root 3. Cool. Woo. Little bit more. Almost done. Okay. 20-foot ladder is set at a 60-degree angle with the ground and fully extended to the 26-foot max. Wait, yeah. That doesn't make sense. Let's change that to, let's say a 26-foot ladder. We'll change that. I'm going to have to fix that. Okay. So how far away from the wall should it be to make a 60-degree angle with the ground? If a window is 20 feet above the ground, will the ladder reach high enough to work on the window? Okay, because it's going to be at an angle, so it's not going to reach a full 26 feet, right? It's going to be a little less than that if you're thinking logically. So let's set up a little picture here. So we got ourselves the ground, we got ourselves a building, and then let's say our ladder is purple, boom, and it is 26 feet long. Now, it makes a 60-degree angle with the ground. That's a right angle, which makes this guy 30. Oh, another 30, 60, 90 triangle. I love them. They're fantastic. All right, so I've got 1, root 3, and 2. Okay, how far away from the wall should it be to make a 60-degree angle with the ground? So that's the ground here. That's across from my 30, so that'll be my x. How high up will it reach, or will I be able to work on a window that's 20 feet up? We'll call that my y, which is across from the 60, so that goes here, and across from my 90 is 26. Let's solve for x first. So I get 2x equals 1 times 26, which is 26, so x equals 13. So 13 feet away is where I should place that. Okay? I don't know if that's actually like a good distance, 60-degree angle. I'm not sure what the proper angle is, but it's pretty close to this. That might be a little bit far out though. I think it would be a little far out. But next one, we just do a math. We do a math here, man. All right, let's cross multiply. So I get 2y equals 26 root 3 divided by 2, and I get y equals 13 root 3. Let's get a decimal for that so we can actually see what we're talking with here, like in real life. 13 root 3. So this is approximately 22.516, so 5 feet approximately, right? 22.5 feet. So that looks like, yeah, I think we're going to be able to work on that window. Yes, we can do that. That's going to reach a little bit higher than that window. You should be able to comfortably work on it. Cool. Another ladder problem. Then I think 14 is our last one, and we are done. All right. It's 13. 15-foot ladder is set at a 60-degree angle with the ground. So same kind of idea here. But I apparently forgot to change some things. I was making some new numbers here. Let's say it's a 30. Hold up. Let's say it's a 30-foot. Okay. So let's do it again. We're going to set it up. Feel free to pause it, try it. I'm going to go with a red ladder this time. So this is a 30-foot long ladder. This is 60 degrees. This is 30. That's 90, right? It says that it makes a 60-degree angle with the ground. Call that x, and we'll call this y. So if I set this all up, 1, root 3, and 2. Across my 30 is x, across from my 60 is y, and across from the 90 is the 30-foot ladder. Now if I cross multiply, I get 2 times x equals 30. Again with my awful 3s. And I get, divided by 2, I get x equals 15 feet. So 15 feet away, right, from the base. Now for y, which I'll change markers again. So we get 2y equals 30 root 3 divided by 2. And I get y. I should have canceled those out too in my work. Okay, and I get y equals 15 root 3. So y is approximately 25.98. So we could even just say about 26 feet. Cool. So how far up will it reach? About 26 feet. Yep. So that'll give us an idea of, how high up this building can go. A 30-foot ladder sounds kind of terrifying. You're going like a story and a half up. That's a ways. When you get up there, it feels a lot higher than it looks from the ground. So I'm not a huge fan of the super high up ladders. I'll go up a story, maybe 2. Definitely gets a little intimidating. All right. The slope of the gable end roof is 612, and the building is 32 foot wide. All right. How tall is the roof? I think we had a 36 foot wide one before. Yeah, this is different. Okay. Well, let's see here. I want to find out how tall this is, right? We'll call that X. what's that length right there? Well, if 32 is the full, then this is 16 feet for half. And I've got a rise of 6 and a run of 12. So this is rise, run. I want to know my rise, and I know my run is 16. So if we cross multiply, I've got 96 equals 12x. Yeah, 6 times 16 is 96. Divide that by 12. And x equals, is that, I don't know, 7.5 or something like that? I think I guessed 7.5 earlier. 8. I don't know why 7.5 is in my head, but 8 feet. That also makes sense. If the slope is 6 over 12, which is like 1 over 2 simplified, every foot you go over, you go half a foot up. So if you're over 16, you're up 8. That checks out, right? Always kind of nice to think logically about it. Sometimes you don't see those things right away. You're still like in the zone with the same math process. Next thing, how long are the rafters, the slope part? So we want to find out that, right? That's part B. We'll call that Y. So if I know two sides of a right triangle, Pythagorean theorem is most definitely my best friend. 8 squared plus 16 squared equals, in this case, y squared. So I'll go ahead and plug that in. I get 64 plus, and that's 256 equals y. So that's 320 squared. And then I got a square root. So let me just double check that. 8 squared plus 16 squared. I don't want to make a mistake. Yep, 320. Square root the 320, and I get 17.888, so 17.9 feet. Since this is an application problem, I will just go with decimals. We could have factor treat that thing, but if I'm measuring this out and stuff like that, I'm going to be going, converting to feet and inches, right? I could convert that as well, but at least we'll just go with decimals right now. And it's going to be just shy of 18 feet for that one, but we could go into inches, voice crack, inches as well. But we won't. All right. I think that's enough for this video. That's 3 videos, the greatest trilogy in all of mankind history there. It's going to be an absolute classic. All right. Have a wonderful day, guys. America, freedom, rock and roll, Costco, Riverdog Jenny on the gram, Yo Ro. Oops, that's upset. There it is. Yo Ro. You guys have a great day. See ya.